please welcome Dr. Jan Sültemeyer. So here we have the opener, in case you would like to drink something.
Very
so
good.
You take
Thank
the blue one, please.
The blue one.
Yes.
Good. Whoa.
It's called the Blue Man Group, actually. So, okay. So wonderful. Great to have you here.
Thanks for having me.
Any highlights yet?
A great conference, super interesting talks this morning. I really enjoyed it. And again, industry coming together to discuss is the best thing we can do, actually. Yeah?
Amazing. So, Jan, where is the topic of circular economy strategically positioned within Avient?
Well, in Avient, first of all, who is Avient? Probably not everybody knows Avient. So we are a leading supplier of master batches and compounds. So that means concentrates of additives and pigments in polymers and plastics, which we sell then to converters. So what we essentially do is giving color and function to plastic. Mm-hmm. And of course, being in the plastic industry, it is very important to have circularity and recycling at the top of the agenda, because this is the key topic which is currently driving, I would say, the plastic industry, especially in Europe.
Do you have like a department, or is it like everywhere across the company?
So it is going throughout the entire company. Mm-hmm. We have, of course, dedicated R&D resources which really focus on recycling, but also on other sustainability topics for plastics, like, for example, PFAS-free solutions or lightweighting solutions. So overall, sustainability for us is at top of the agenda and also at top of the vision. So very important point.
So you mentioned in our pre-talk that the amount of recycled material needs to increase significantly. So, however, the more recycled loops there are, the lower the quality is. What are the biggest challenges in plastics recycling today that still lack a real solution?
I think we heard a lot already this morning, and I brought 2 or 3 slides. Maybe there's already one.
So the clicker.
Yeah, no problem.
I will get it.
And basically what we can say, we are not yet in a real circular economy. I would say currently it's a recycling economy. But after a few cycles, the material anyway has to go to the waste bin or maybe to the park bench or the flower pot, and then there's a certain end of life. But what we want to achieve, obviously, is a circular economy. And we are by far not there because the system simply doesn't work. And why is that the case? Well, if I look at the next slide, we can see that the more we turn the material in the circle, we add more and more heat histories to the polymer. And with every melt point achieved for the polymer, we degrade the polymer, like you already said. So we are accumulating more and more degraded polymers, rest of ingredients which was before in packaging, which makes the quality of the plastic less and less and lower. And essentially, when we look at what is currently planned in the PPWR, in the Packaging and Packaging Waste Regulation, we try to maximize the content of PCR in packaging articles. Mm-hmm. And in this slide, you can basically see the more PCR you put in, the more material you will have that has already accumulated debris and waste from the previous cycles. So if you really want to have a circular economy, we must not only look at one cycle, which is normally where we think, it's recyclable, it's great, but we have to think it through. We have to think what happens after the next cycle and the next cycle. Because if everybody would now switch to 100% PCR, the recycling stream, the quality of the recycling stream would probably go down the drain immediately. Mm-hmm. So we cannot currently sustain that. We need always to fresh up with virgin or chemically recycled material. Yeah. Mm-hmm.
So tell us a little bit more about CycleWorks. Sounds very exciting. It's an innovation lab where you work with partners to improve the longevity of recycling streams. Exactly. So why is this important for your company? Well, I think we know why. But what is exactly your team tackling with?
So the basic idea of CycleWorks was that we said, when we want to innovate in mechanical recycling, we have to reproduce the process. Mm-hmm. So that was the starting point. We said we have to replicate the key steps of mechanical recycling, meaning we have to make our own specimen, bottles, films, chips. We have to grind them to flakes. We have to wash the flakes under industrial conditions and then re-extrude them to make our own PCR and then go in the same circle again and again and again, like multi-loop recycling, as I just explained. And that's the foundation of it. And by now it really became a team of experts in mechanical recycling who can really understand not only the recycling protocols like Recyclars or APR or EPBP, which we can fully replicate, but we can also build our own models by mixing certain wastes together. Like, for example, if you have a polypropylene, polyethylene mixture, we can build the models and see which kind of additives actually help to compatibilize them. And we use this CycleWorks also as a collaboration and networking part. So we invite customers over to work together with them to improve the recyclability of their products.
Is it really a lab?
Yes, it is. It's a pilot scale lab. We turn material in the 50 to 100 kilo scale in a circle. So it's significant. We have like enough material to really make bottles or films or chips. Even after 3, 4, 5 cycles, so we can really see what is the impact of our materials on the recycling process. But we can also start with let's say, flakes from the market and say, how can we upgrade these materials and bring them to a better quality?
Nice. So is it like a freies Radikal, free radical within the company, or is it integrated?
No, it's fully integrated into the research landscape. So we have additive teams who develop new additives, teams who work on colors, and we are all really connected and closely work together, and the recycling expertise sits now in this CycleWorks lab. Yeah.
And are there any ideas yet that are published, or are there any examples of your R&D?
Yes, we had quite a few products which we already launched into the market, like certain stabilizers which keep the polymer stable over many cycles. We have examples of compatibilizers to improve the quality of, as I already said, polyethylene, polypropylene mixtures to improve impact strengths of certain products. So these are things which have been published and also been rewarded with prizes, for example, at the PRSE, at the recycling show from Plastic Recyclers Europe. Yeah.
It's also nice when you get a little bit of appreciation, right?
Yes, exactly.
For this hard work. Yeah, I can imagine that. So in our previous conversation, you mentioned 2 key approaches to plastics recycling. So the one designed for recycling and the other one is designed from recycling. Could you explain these 2 concepts and key challenges?
So, the other way to say it is basically the vitamin or the aspirin for plastic. So the aspirin for plastic is taking away the headache maybe of the converter. So it's solving a low quality problem that a converter has with a PCR and trying to upgrade it to higher quality. That would be the design from recycling. So I come with a PCR, I try to bring it to a higher quality. With a compatibilizer, bringing 2 polymers together which are hard to separate. With a stabilizer, with a chain extender to repair broken polymer chains, for example. With a tool which we call the color prediction tool, where we basically can start with a gray PCR material and can predict which kind of colors are actually feasible based on that gray. So we can predict, dear brand owner, forget this yellow, but you can go for this nice green, for example. And that's a design from recycling. Design for recycling, I think everybody knows, is how do I design my product from the beginning on to make it best recyclable at the end. That could be that we use detectable colors, meaning if you have a black color, it's very difficult to detect by the detection machine. So we worked with Tomra, for example, in a project, and we had Tomra already here today, to verify that our black solutions which we supply don't contain carbon black and are fully detectable in the recycling stream. Or stabilizers which will stabilize the material over many, many cycles. These are examples for the vitamin, keeping the material healthy and strong as long as possible.
That all sounds very positive. I mean, of course, we stay positive here in this hall, but there is also the other side of the coin, right? So what challenges are really, really hard to tackle? Are there some, if you think about these 2 concepts?
I think a very big challenge is removal of odor, for example. So this deodorization can be done physically by blowing air through the PCR. But from a chemical side, it's very difficult to capture all these small odor molecules. And we just had a very interesting presentation from Fraunhofer on the other stage, tackling exactly the same point. Or removing colors from a recycling material is also virtually impossible.
Yeah. So Many companies proudly highlight sustainability in their strategies, but when it comes to implementation, how well are they delivering on their commitments? And what are the main barriers?
You know, there's a lot of pledges out there from brand owners. Also, Ellen MacArthur Foundation has a very nice chart every year showing where companies, brand owners are basically versus their promises. And most of them are actually behind. And that's not because they're not willing to do it or not having the ambition to actually achieve the PCR content targets, which they actually promised maybe 5 years ago. But it's turning out to be much more complex than they thought. Because there's simply not enough good material in the market, especially if you want to talk about food-grade material. From a mechanical recycling stream is very rare, it's almost not existing. And food-based companies who want to actually implement that material, they really struggle, let alone maybe PET for bottles, it's a different story. But they are actually currently not able to achieve their targets. And that's a big headache for the entire industry, especially looking at the upcoming PPWR, which is forcing everyone to integrate a certain amount of PCR. And I think, honestly speaking, there's a big worry in the industry that we are not able to achieve it. What happens actually if there's not enough material which is feasible to integrate? And then at the end, people cannot sell their materials anymore.
And also with a view on the global market, which is then regulated differently, right? So we're all global market players.
Exactly.
Yeah. What are the main barriers?
Other barriers are, first of all, is the availability of the material, but then also the willingness to, or let's say, the willingness to fund and implement new technologies. So I had a few discussions already here, and look into the audience, I see already a few people I had the same discussion with. If there's a new technology which would basically change the way we work in the recycling stream, and we all would need it, for detection, for example, or for putting a digital product passport to a product, if it's an additional investment, if it costs more, if it's complex to implement, well, still brand owners, to be very honest, they shy away from these. So we have a lot of good pilots, a lot of very good concepts, but not a lot of very good implementations of these things currently.
Let's talk about a very good implementation. So can you share some inspiring best practices from your customers where innovation has accelerated circular economy efforts?
Maybe I have two examples which were also.
Or 4. We have time.
Of course, I need to be careful. It has to be kind of public, so I cannot talk about stuff which is under NDA. But the first thing maybe, which was quite successful, was this black story, where we said we have to develop a detectable black material, and we were approached by Unilever, who has this famous Axe material. The Axe shampoo and shower gel, and they wanted to make it detectable. And that was basically the start of this project, where we worked together with them and the company Tomra. So it was all in the press. We talked about that at the K show. And we developed this black solution, which is now in all the black packaging of Axe and Lynx, how it's called in the UK. And making these products fully detectable. And that was really a value chain collaboration where we worked with the sorter, we as a chemical company giving the color, and the brand owner behind it actually to qualify that. Yeah. Another example is with this color prediction tool. L'Oreal approached us. They wanted to make these red can shampoos, which, it's not my thing, the shampoo, but maybe you know the shampoos. And they exist in 7 different colors, I think, the bottles. And they said, we have a certain PCR, we want to make 7 colors. Which colors can we achieve? And with this tool, basically, we predicted, or we basically calculated the right colors for them, which they then successfully launched in 100% PCR packaging. Yeah.
Cool. Yeah. So your eyes are shining as well. That is also really important to do a good job in this field and to have the energy. So what excites you most about your work?
I think it's, I'm a chemist, I'm in the plastic industry, so you could say I'm on the evil side, we do plastics. But I think it's the contrary. So I'm quite proud, also my son, for example, is proud that his father is working in the recycling field, so making plastics more sustainable. And that's actually a good feeling that you can work in a field where there's obviously a problem with plastic waste. But plastic is not a bad material. It has a low carbon footprint, it's easy to produce, lightweight. So it's actually a very sustainable material, but we have a waste problem. And I'm quite proud to say I work actually at the forefront to solve this waste problem. And that makes me happy and actually drives me every day. So
that's a very good reason, actually.
Yeah.
So what would be your call to action for the audience here? So we talked a lot about mindset shift, about innovation, be open. What would be your call to action?
Stop piloting, start implementing.
Okay. Yeah.
So that's maybe going towards brand owners, I think, mainly. Because I think there's a lot of good ideas out there, but we have to have the guts and the willingness to implement them and actually to change the way we work. We always try to, be on the safe side and try to have drop-in solutions, not to invest too much, not to make this next step. But we need that, otherwise we will never achieve the targets we all set ourselves.
Yeah. So what are you most looking forward today, so the rest of the day and tomorrow? What is your target?
Talk with as many of the startups out there, because I think there's a lot of good technology. Getting to know these people, listen to all the presentations, and network.
Network. Yeah, that's right. So I have one final question for you.
Yeah.
And I love this question. So if you could invent something that would really move the circular economy forward, what would it be? It doesn't necessarily have to do with what you're doing. But you like inventing, so...
So speaking from what we are currently doing would be the fully removable colorant in mechanical recycling. I think all PCR suffer from the color, from the grayness of this material. If we would have colorants which you can basically switch off and they're gone, that would be great.
How could this be? With a laser, like MIB?
With the laser, you wash them out, you destroy them some way. Yeah. It works with chemical recycling. But in mechanical recycling, which is easier and cheaper, it doesn't work.
Well, actually, it's a really smart answer. So it's really a tough question, right? So what would you invent? So maybe you ask yourself, what would you invent to really engage yourself in the circular economy? That's really cool. So thank you very much for your time. You're still here around?
I'm here, I'm around.
So if you have any more questions, just jump to Jan. Applause for you. Thank you.
Thank you.